Hi all, in this video we will study proofs involving sets like set equality, power set, subset, set identities. These concepts are very important from gate exam point of view and also in the set theory. So let's start. So these set operation we already know what is the complement of a set, what is set difference, intersection, union, cross product. All these set operations we have already seen. But what is the meaning of A is subset of B? Okay, so this subset concept is very important. So understand what is the meaning when we say A is subset of B, what it means. This we have already seen, but let me just give you quick overview that A is subset of B. That means every element of A is element of B. So this is very important. Remember, A is subset of B. It means every element of A is element of B. This is the definition. This means A is subset of B, and it simply means that if these are the elements of A, then every element of A is also element of B. So this is how you can, this is the Venn diagram of subset. A is subset of B. So this is the Venn diagram. Okay, and in this Venn diagram you can clearly see every element of A is also element of B. In B you can have extra element, but the point is every element of A must be in B. Okay, these extra elements can be there in B. So this is the definition of A is subset of B. Every element of A must be in B. Okay, so for example, this set is subset of this set, because you can notice every element of set A is also element of set B, because you can notice this 2 is element of set B, 4 is element of set B, 6 is element of set B. So every element of set A is also element of set B. So I can say set A is a subset of set B. So I can say basically this is a subset of B. Now you can clearly see, and also there is something called proper subset. Proper subset means subset other than itself. So I can say basically A is proper subset of B. It means A is subset of B and also A is not equal to B. So this is the idea. So you can notice this 2 4 6, this is proper subset of B, because you can notice A is subset of B and also A is not equal to B. So I can say that this A is a proper subset of B. Okay, so this is the idea. Remember, in subset, for example, this A, if I tell you like this set is a subset of this set. If you notice, so both set are equal. You know A is equal to B. The point is A is a subset of B, but you can notice A is not a proper subset of B, because proper subset means, okay, I can say that X is a proper subset of Y. This is the symbol for proper subset. So when can you say that X is proper subset of Y? If and only if X must be subset of Y, means every element of X must be in Y and X must not be equal to Y. So proper subset means basically proper subset of any set S is any subset other than S. Okay, so this is the idea. Proper subset of a set S. Proper subset of a set S is any subset other than S. Is any subset other than S. So this is the idea of a proper subset. So you can clearly see A is subset of B here. Now, okay, how many subsets are there? This we have already seen that if you have a set with n elements, then number of subsets will be 2 power n and number of proper subsets will be 2 power n minus 1. Okay, so for example, if your set is banana, oranges, strawberry, in your set A you have 3 elements. So how many subsets will be there? There will be 2 power 3 means 8 subsets. And how many proper subsets will be there? That will be 2 power n minus 1 7. This one basically we are removing this set A itself. Okay, because set A is a subset of A, but set A is not a proper subset of A. So for example, for this set the proper subsets are these 7 are the proper subset of set A. Okay, now let's see, if you want to prove that S is subset of T, then how to do that? Okay, so this is the idea. To prove, if you want to prove that S is a subset of T, okay, if you want to prove this, then what you need to do? Then basically the idea is this: for all elements we need to prove, okay, for all elements we definitely need to prove that if it belongs to S, then it also belongs to T, because S is subset of T, that means every element of S is in T. So every element of S, any element, if it is in S, then it should also be in T. So this is the idea. To prove S is subset of T, this is what you need to do. So what you can do, basically the idea is this: you can assume some X, okay, you can assume some element X, okay, which belongs to S. So this is what you can assume. You can assume that some element x belongs to S. Then okay, then what you do? Then you show that okay, then you show that x also belongs to T. So if we can do this, this is the procedure. Okay, so let's assume, so we assume that some element belongs to S, and then okay, after applying some rules that we already know. Okay, so basically the knowledge that we already know, okay, the knowledge okay, that we already know, that we already have. So from that, what you do, the knowledge that you already have, okay, from that knowledge, what you do, you show that x also belongs to T. If you can do this, then I can say, okay, then I can say that, okay, remember this x is a random element. Okay, this x is some random element, and we are saying that any element x, if it belongs to S, then it also belongs to T. Okay, basically for random element we are proving, for arbitrary element we are proving that if it belongs to S, then it also belongs to T. Then I can say that every element of S is in T, so I can say S is subset of T. This is the method if you want to prove that S is subset of T. So idea is very simple. Let's assume that X belongs to S. Then you apply the concepts that you already know, okay, logical deductions, and then you prove that X also belongs to T. And this will prove that for any element x, if it belongs to S, then it also belongs to T, and that is the definition of subset. So I can say that S is subset of T. So this is the idea. So remember, we can apply the direct approach. Basically, if you want to prove that A is subset of B, then you can apply the direct approach. Direct approach means assume some element is in A, and then you prove that that element is also in B. You can also apply the contrapositive approach. What you can say, okay, so basically this idea is this. Okay, if you want to prove these two things, you can do. If you want to prove that S is subset of T, if you want to prove this, then either you can do this. What you can do, that X belongs to S. Let's assume that okay, some element is in S, and then you show that X also belongs to T. Okay, or what you can do, or another approach is this. What to do, the contrapositive. What is the contrapositive of this? The contrapositive of this is basically assume that X is not in T, then you prove that X is also not in S. Okay, so basically either you can apply this direct approach, or you can apply this contrapositive approach. Both are correct. You can apply any one of them. Most of the time we will apply this is okay, this is basically most frequent. Okay, so most of the time we will apply this. I can say this is most used, but you can apply this also, you can apply this also, that is your choice. Okay, now let's see, how can you say that two set are equal? Okay, what is the definition of set equality? So set equality, when can I say that S is equal to T? Two set S is equal to T. The definition is very simple, that they should be exactly same. Every element of S should be in T, and every element of T should be in S. So I can say basically, okay, if any element S, okay, if any element belongs to S, then it should also belong to T, and if any element belongs to T, then it also belongs to S. So this is the idea. Then we can say that these two set are equal. Equal means they should be exactly equal. Every element of S must be in T, every element of T must be in S. Okay, so these two things should happen. Now remember, what is this? What is the meaning of this statement? The meaning of this statement, that any element, if it is in S, then it should be in T. The meaning is basically that S is subset of T. Okay, and this statement, what is the meaning of this statement? The meaning of this statement is that okay, T is a subset of S. So I can say that two set are equal if and only if S is subset of T and T is subset of S. So if you want to prove that S is equal to T, two set are equal, then what you have to do, you have to prove that S is subset of T, and also you have to prove that T is subset of S. So these two things you have to prove. And also, if you already know that S is equal to T, if this information you already have, then it means S is subset of T and T is subset of S. So all these concepts we already know, but just okay, just for quick overview, I told you. So how to prove set A is equal to B? The idea is very simple. Prove that A is subset of B. Also prove that B is subset of A. How to prove A is subset of B? Very simple. Assume that some element is in A, then you prove that it is also in B. Similarly, how to prove that B is subset of A? Very simple. Assume that some element is in B, then you show that that element is also in A. So this is the idea. Now let's take some examples. Let's solve this question for any set A, B, C, D and A, B, C, D, E, where A is subset of B union C, B is subset of D, C is subset of E. Show that A is subset of D union E. So this is the question. Let's solve it. So the data that is given to you, okay, the data is this, that A is a subset of B union C. B is a subset of D. B is subset of D. From these two information, what can I say? So remember, A is subset of B union C. So if this is B, okay, this is C. Let's assume this is C. Then A is basically subset of the, okay, A is somewhere here. A is maybe, okay, maybe this is A. So A is subset of B union C, and B is a subset of D. So from here, remember, B is a subset of D. So because B is a subset of D, so I can clearly say that A, let's assume this is A, then I can clearly say that A is a subset of C union D. So from these two, I can say A is a subset of C union D. Okay, subset of C union D. Because remember, the point is very simple. A is a subset of B union C, and B itself is subset of D. So B is a subset of D. So I can say that every element of A is already in B union C. Okay, every element of A, if any element of A you take, then that element is already in B union C. Okay, and you can notice that every element of B union C, every element of C is in C, and also every element of B is in D. So I can say every element of B union C, that is also in D union C. So I can say that X also is in D union C. So this is the idea. So I can say from these two, I can say that A is a subset of C union D, and C is subset of E. This C itself is subset of E. So from this, I can say, so because A is a subset of C union D and C is a subset of E, so from these two, I can say that A is a subset of E union D. Okay, so this is what the question is asking. A is subset of E union D. Yes, this is correct. The idea is very simple, that if you take any this, what is the meaning of this? What is the meaning? The meaning is this, that for any element X, whatever element X you take, if it belongs to A, then it also belongs to C union D. Okay, and also you can notice every element of C union D is also, because every element of D, this element X, this is in C union D, this element is in C union D. So I can say that X is in either C or X is in D. What this means? This basically means that X is in C or X is in D. Okay, now if X is in C and C is subset of E, because we already know C is subset of E, so if X is in C, then I can say X is also in E. Okay, and you can notice if X is in D, then I can say X is in D. So now from these two, X is in E or X is in D. So from these two, I can say that X belongs to C, okay, D union E. X belongs to D union E. And you can notice that X belongs to A, so X belongs to D union E, and this is the proof that A is also subset of E union D. So from this question, you can basically, you can see this fact. Okay, so from this question, you can make this fact, that if A is a subset of B and B is a subset of C, then I can say that A is a subset of C. Okay, so this subset relation, this subset is basically transitive. I can say if A is a subset of B, okay, and B is a subset of C, then I can also say that A is a subset of C. So this is the fact that you can use in this question. Okay, let's see the next question. For any set A comma B, show that, okay, so this is what we have to prove. We have to prove that A intersection B is subset of A union B. So the method one is Venn diagram method. Okay, so you can just apply the Venn diagram method, and using the Venn diagram method, you can prove this type of questions. So for example, you can create like this. Okay, this is set A, this is set B. Now you can, okay, so in this Venn diagram, so this is the Venn diagram. In this Venn diagram, I can create four areas. Okay, so this is the area 1, this is area 2, this is area 3, this is area 4. So total 4 area we have. This area 3 is basically A intersection B. So I can say A intersection B is basically area 3. Okay, so that is area 3. A intersection B, that is area 3. Okay, and this area 1, this outer area is the area 1. This outer area, this is the area 1. Now What is A union B? A union B is basically 2 3 4. This area is A union B. This 2 3 4. This is the A union B area. Now from these two you can clearly see, that this A intersection B is area 3, A union B is area 2 3 4. So I can say that A intersection B is a subset of A union B. And this is what we wanted to prove. Okay, so this is the proof. Another method, the method 2, you can apply the definition. So this is what we want to prove, that A intersection B is a subset of A union B. So basically here we have, this is your set S and this is your set T, and what we have to prove, we have to prove that S is subset of T. Then what is the idea, the method? Okay, so the method 2, is basically assume that some element belongs to S. Assume some element belongs to A intersection B. Now from, okay, so this is our assumption that some element belongs to A intersection B. What this means? This means that X is common in A comma B. So I can say X is in A and I can say that X is in B. Okay. Now you can notice X is in A. That itself is enough. X is in A and X is in B. So X is in A. That itself is enough. That itself is enough to say that X is in A union B. So this is enough. We don't need this. But the point is X is in A and X is in B. From this I can say that X is in A union B. Okay, so this is the idea. So we assume that X belongs to A intersection B, and then we apply the concepts that we already know. We already know that if X belongs to A intersection B, then X belongs to A and X belongs to B. From this you can say that X belongs to A union B. This is what we wanted to prove. Okay, so from this I can say, S is a subset of T. So this is the idea, this is the proof. Let's see the next question. Okay, prove that A minus B is a subset of B. So first of all you can apply the Venn diagram method. So let's apply the method 1. Okay, so method 1 is basically the Venn diagram. In the gate exam you should apply this method because this method is, okay, less time taking. It will not take much time. The method is this, that you have set A. Okay, so this is your set A and you have set B. This is the set B and this is your universal set. Okay, now in this Venn diagram you can create total 4 area. So this is area 1, this is area 2, this is area 3, this is area 4. Total 4 area we have. Area 4 means this is the area 4, this is the area 3, this is the area 2, and this outer area is area 1. This outer area is the area 1. Okay, now you can notice that what is the area of B? If I ask you, area of B, that is 2 comma 3. So this is the area of B, this 2 comma 3. And what is the area of A minus B? A minus B, this is the area of A minus B. A minus B means elements which are only in A, not in B, which are only in A. So A minus B area is 4. This area is the A minus B area. Now what is the area of A minus B? See, remember what is the area of A? Area of A is 3 comma 4. This is the area of A. Now what is the area of A minus B? Remember the area of A, that is 3 comma 4 minus. Okay, the area of A minus B is 4. So from this 3 comma 4 area, if you remove the 4 area, then what you will get? Then you will get area 3. So this is the area 3. Remember, this is the area 3. I can say this is the area of A minus B. Now from here I can say that this is the area of B. Okay, and you can notice this is the area of A minus B. So I can clearly say that A minus B, this is subset of B, because this is the area 3 and this is area 2 comma 3. So I can say that this A minus B, this is a subset of B. So this is the proof. So this is the idea of proof. Okay, so finally you can write this here. You can write that, and this is okay. So we have proven that A minus B, this is a subset of B. Let's see the next. Okay, another method, method 2. In the method 2 you will apply the definition. So again, this is what we want to prove. We want to prove that A minus B, this is a subset of B. So this is set S and this is basically set T, and we want to prove that S is a subset of T. Then if you want to prove S is subset of T, then what you will do? Then first you will assume that some element X belongs to S. Some element X belongs to S. Okay, so just assume that some element belongs here. Then we will prove that that element X also belongs here. So x belongs to S. What it means? It means x is in A minus B. Okay. Now these things we already know that if x belongs to, in the last lecture we have already seen that if x belongs to A minus B, then what can you say? Then I can say that x belongs to A and x does not belong to B. So this we already know. So I can say that x belongs to A minus B. So from this I can say that x belongs to A, okay, and x does not belong to A minus B. X does not belong to A minus B. What that means? X does not belong to A minus B. This simply means, okay, if x is not in A minus B, it simply means that either x is not in A or x is in B. So this is the idea. Okay, x is not in A minus B. It means either x is not in A or x is in B. So this we can apply here. So this is what we have. X is in A and x is not in A minus B. X is in A, and from this what you can say? From this I can say that either x is not in A, either x is not in A or x is in B. Now you can notice either this will happen or this will happen. So you can clearly see that x is already in A, so this cannot happen because x is already in A, so definitely this cannot happen. Okay, so we can basically say that this cannot happen, this will happen. Okay, so because there is or here, either x does not belong to A or x belongs to B. So because already we know x is in A, so this cannot happen. So I can simply say that x is in A. Okay, so definitely this will happen because this cannot happen. If this cannot happen, then definitely this will happen. So I can say x is in B. Okay, so this is the idea, x is in B. So what you can say finally? So from here you started, you assume, okay, we assumed that this x belongs to this set. Now finally we got that x belongs to B. So from this we can say that S is a subset of T, or I can say that A minus B, this is a subset of B. Okay, so this is the proof. This is how you can prove. Let's see the next proof. Now let's prove that A union B intersection C, this is subset of A union B, okay, intersection A union C. So let's prove this. So this is what we have to prove, that A union B intersection C is a subset of A union B intersection A union C. Okay, this is what we have to prove. So first we will prove by method 1, that is Venn diagram. Okay, so let's apply the Venn diagram method, and this is the most simple method. Okay, in the gate exam you can use this method. So in the Venn diagram, what you do, you create areas. Okay, the best method is this. See, okay, what you do, you can create areas. Let's assume this is set A, let's assume this is set B, and let's assume this is a set C. In the Venn diagram, if you have three set, then how many area will be there? So you can mark the area 1, area 2, area 3, area 4, area 5, area 6, area 7, area 8. Okay, so these are the areas that we have. So total 8 area we have. Now from this, what is this area? Like B intersection C area. What is this area? B intersection C, the common area of B comma C. So the common area of B comma C is 8 comma 6. So this 6 comma 8 is the area of B intersection C. What is the area of A? Area of A is 2578. This is the area of, okay, area of A. This is the area of A, means 2578. This is the area of A. What is the area of union? A union B intersection C. What is the area of this union? Means union of these two. Okay, A union B intersection C. So the union of these two, that will be 25678. This will be the area, okay, for the union. For this, the area will be 25678. Now what is the area of A union B? What is the area of A union B? A union B area means common area of A comma A union B. Common area, sorry, no, A union B means the complete area of A comma B, the complete area of A comma B. So the A union B, that area is basically 2 3 5 6 7 8. This is the area of A union B. What is the area of A union C? A union C area means this area, this complete area of A comma C. So this area is basically 2 4 5 6 7 8. This is the area of A union C, 2 4 5 6 7 8. Correct. Now what is the area of A union B intersection A union C? Means the intersection of these two. the intersection of these two. So basically the intersection of these two, what that will be, A union B intersection A union C. Remember the area of A union B, that you already know, 2 3 5 6 7 8, 2 3 5 6 7 8, and the area of A union C, that is 2 4 5 6 7 8, 2 4 5 6 7 8. What is the intersection of these two? What is the intersection of these two? That will be 2 5 common area. Okay, so the common area will be basically 2 5 6 7 8. This will be the common areas. This is your A union B intersection A union C. Okay, so this is the area of this expression. So the area of this we found and the area of this we found, and you can notice both are same. Okay, so this A union B intersection C, that also the area of A union B intersection C, that is also 2 5 6 7 8, that is also 2 5 6 7 8. So I can actually say that they are same. Okay, so they are actually equal. They are actually equal. I can say that they are actually equal. From the Venn diagram method you can prove that they are actually equal. Okay, so this A union B intersection C, this is equal to A union B intersection A union C. This is known as distributive property. After some time I will tell you that this is basically the distributive property. We can distribute the union in the, okay, over intersection. This union we can distribute over intersection. This is the distributive property, but using Venn diagram you can prove it very simply. Okay, let's see the another method, the method 2. Okay, this method 2, let's try. In the method 2 what we will do, so in this method 2 basically this is the set S and this is the set T, and we have to prove that S is a subset of T. This is what we have to prove. Okay, so I can say to prove that S is subset of T. So what you will do, you will assume, okay, so very simple, just assume that X belongs to S. Okay, this is what you assume. Now what this means, this means that, okay, so I can say X belongs to S. S means A union B intersection C. Now from this what you can say, X belongs to A union this. What it means? It means that X belongs to A or X belongs to B intersection C. So here I can say that either X belongs to A or X belongs to B intersection C. So okay, now you can clearly see either this will happen or this will happen. Either this will happen or this will happen, or both can happen. Okay, so there is or here. Now here you can make two cases. Case 1, see, either this will happen or this will happen or both will happen. At least one of them will happen. Case 1, case 1 if this happens, if this happens, okay, and case 2, case 2 if this happens. At least one of them will happen. Either X is in A or X is in B intersection C. At least one of them will happen. So either case 1 will happen or case 2 will happen or both will happen. Now in this case X is in A. If X is in A, then X is also in A union B. Okay, then I can say X is also in A union B. So from this I can say that X is also in A union B. I can say X is also in A union C, because we already know this, that if X belongs to A, then I can say that X also belongs to A union B. This we have already seen in the last lecture. Okay, so X belongs to X belongs to A, it automatically means X belongs to A union B. It automatically means X belongs to A union C. From these two, X belongs to A union B and X belongs to A union C. From these two I can say X belongs to A union B intersection A union C. Okay, so basically in this case 1, what we have proven, in this case we have proven that X belongs to T. Okay, in this case 1, so remember we assume that X belongs to S. Now in this case 1 we have proven that X also belongs to T. Okay, so in this case 1 I can say that X is that S is subset of T. So I can definitely say that S is subset of T in this case 1. What will happen in case 2? In case 2, X belongs to B intersection C. What this means? This means that X belongs to B and X belongs to C. Okay, now X belongs to B, it automatically means that X belongs to B union A. X belongs to C, it automatically means that X belongs to C union A. From these two, what you can say that, okay, X belongs to B union A and X belongs to C union A. So from these two I can say X belongs to A union B and X belongs to A union C. From these two basically I can say that X belongs to T. Okay, so I can say x belongs to t, and that's why I can say that x s is a subset of t. So this is the idea. So what we have done, we are assuming that some element x belongs to s, and we are proving that that element x will also belong to t. So we have proven that s is subset of t. So this is the idea. Remember these type of things. Okay, all these points, like if x belongs to a, then x belongs to a union b. This point we have already seen in the last lecture. Okay, you can watch the lecture. The lecture name is understanding set operations. In that lecture I have already told you all these things. For example, if x does not belong to a, then I can definitely say that x does not belong to a intersection b. Okay, similarly, if x does not belong to a union b, okay, then I can say that x does not belong to a and x does not belong to b. Okay, so basically all these things we have already seen in the last lecture. X belongs to a minus b if and only if x belongs to a, x does not belong to b. Okay, similarly we already know that if x does not belong to a minus b, then basically what it means, it means either x is not in a or x is in b. So these things, all these fact we have already seen in the last video. That is very important. If you understood the last video, okay, the name of the video is understanding set operations. That video you can watch. Okay, understand all the set operations clearly. All these facts I told you in the last class. Okay, I have already given you the explanation, proof and everything. Okay, so if you understand these things, then you can very easily solve this type of questions, because you can notice what we are doing. We are using the definitions of set operations. Okay, we are assuming that some element is here. If some element is here, it means okay, if x is in a union b intersection c, it means x is in a or x is in b intersection c. So you can make two cases. Either this will happen or this will happen or both will happen. But you can notice in both the cases, case 1 or case 2, in both the cases I can say that x belongs to t. Okay, so this is the proof that s is a subset of t. So this is the idea. Let's prove this. So prove that a bar minus c minus b minus c, that is subset of a bar minus b minus c. So again, this is the set S. Let's call this set S and let's call this set T. So what we have to prove? We have to prove, basically this is what we have to prove. So prove that S is a subset of T. And we already know that if you want to prove this, then what you can do? You can assume that some element x belongs to S. Okay, just assume this. So x belongs to a bar minus c minus b minus c. Okay, now remember, x belongs to a bar minus c minus b minus c means x belongs to this minus this. What this means? This simply means that x belongs to this but x does not belong to this. So from this I can say, remember, x belongs to a bar minus c this minus b minus c. From this, what this means? This means that x belongs to a bar minus c. Okay, and x does not belong to b. X does not belong to b minus c. Okay, x belongs to a bar minus c. What this means? Okay, what this will mean? This will mean that x belongs to a bar and x does not belong to c. Okay, and x does not belong to b minus c. What this means? Okay, this means that either x does not belong to b or x belongs to c. Okay, now you can notice x does not belong to c. This we already know. We already know x does not belong to c. So this cannot happen. This x belongs to c. See, either this will happen or this will happen. Now you can notice that either this will happen or this will happen or both will happen. But you can notice x does not belong to c. Okay, so this cannot happen. If this cannot happen, then definitely this will happen. So I can say, from this I can say, okay, from this I can say that x belongs to a bar, x does not belong to c, and x does not belong to b. So this is what we have. We have x belongs to a bar, x does not belong to c, x does not belong to c, and also x does not belong to b. Now from this, what you can say? So what we want. Basically we want that x should be in a bar minus b minus c. So from this, what we can say? X is in, okay, x is in a bar, this you know. X is not in b. From this, what can you say? From this I can say that x is in a bar minus b. Okay, and you can notice now x is in a bar minus b, and you know x is not in c. From these two, what you can say, from these two I can say that x belongs to this, x does not belong to this. So I can say that x belongs to a bar minus b minus c. So these are the facts we are using, if you notice. Okay, so you can notice x belongs to any, like x belongs to set a minus b if and only if x belongs to a and x does not belong to b. Also, x does not belong to a minus b if and only if x does not belong to a or x belongs to b. So basically these facts we are using. Similarly, if you already know that x is in a, x is not in b, so from this I can say that x is in a minus b. Okay, so these all these facts we have already seen in the last video. You can watch the last video. The last video is very important. Understand everything that I have explained in the last video. Okay, understand the set operations, and then you can solve these questions very easily, because all the concepts that we have seen in the last video we are using here. Okay, so this is what we have done. So we have proven that x belongs to a bar minus b minus c. Okay, and this is basically, this means basically x belongs to t. Okay, so we have proven that if x belongs to s, then x belongs to t. Okay, so I can say that s is a subset of t. Okay, so this is the proof. In the next video we will study set identities and the concept, the method that we have seen in this video. Okay, so this method we will apply on all these identities. Okay, on your screen you can see many set rules, basically set laws, or you can say set identities. All these things we will study and we will prove them using the method that we have seen. Okay.